Welcome, curious minds, to another deep dive. Today, we're embarking on a journey into a concept so profound, it might just reshape your understanding of reality itself.
It's definitely one of those topics.
Yeah. Our stack of sources explores this, well, radical idea that consciousness isn't merely a complex byproduct of biological brains, but could actually be fundamental.
Right, woven into the very fabric of existence down to elementary particles.
Exactly. So our mission today is to navigate these, frankly, astonishing claims, sift through the intriguing evidence, and, try to uncover how consciousness, memory, and information might be interconnected at the most basic levels.
It pushes the boundaries for sure.
Prepare to rethink some core assumptions about what it means to be aware. Okay, let's kick things off with a truly mind-bending assertion from our sources. The idea that elementary particles, think electrons, photons, aren't just inanimate bits of matter.
Right, they seem to exhibit some form of
Well, intelligence.
intelligence in an electron. Well, a key point highlighted by physicist Danah Zohar is the observation that these particles appear to know about changes in their environment and respond accordingly.
Respond how?
It suggests a responsiveness that goes beyond just, simple physical laws reacting.
Okay, this immediately brings to mind the classic double-slit experiment. But our sources dive into a variation that takes this concept, well, further.
Yes, exactly. And what's crucial here is the interpretation they draw from it. A group at the Weizmann Institute in Israel did a double-slit experiment with electrons, standard setup.
Okay.
But what they observed, as reported by eBooks, was that the interference pattern, that sign of the electron behaving like a wave going through both slits at once.
Yeah, that way of behavior.
That pattern diminished the longer they observed the electrons passing through.
Diminish, just from watching.
That's the observation. The implication drawn in the sources is that if an electron somehow senses it's being watched, it seems to choose a single path. It shifts from acting like a wave to acting like a particle.
So wait. It's not just that the measurement affects the outcome, which we know happens in quantum mechanics.
Well, the interpretation presented here goes beyond that. It's framed as the particle itself having some form of awareness of being observed.
Yeah, that's a huge claim. Tiny particles having awareness. What's the core argument for this, according to the sources? Do they address other, maybe more conventional interpretations?
The sources we looked at primarily lean into this interpretation of awareness, yeah. Renowned physicist David Bohm, for example, goes even further. He suggests that, and I'm quoting loosely here, in some sense, a rudimentary mind-like quality is present even at the level of particle physics.
A mind-like quality.
Yes. And he suggests that as we go to subtler levels, this mind-like quality becomes stronger and more developed. Essentially, the proposition is that consciousness could be as fundamental a property as mass or spin or charge.
Wow.
And that different particles might even possess different degrees of it.
So it redefines alive or aware completely, taking it way beyond biology.
Precisely. That's the radical shift in perspective being proposed.
Okay, so if particles possess this rudimentary mind-like quality, what are the conditions for it? When does this consciousness actually, show up or become observable? What makes it more than just a metaphor?
Right, good question. Bohm posited that a particle possesses a rich and complex inner structure which can respond to information and direct its self-motion accordingly.
An inner structure that responds to information.
Yes. And this mind-like quality, he notes, becomes more evident in, say, more massive particles, and particularly in specific quantum states. He calls these superparticles.
Superparticles.
Think of things like Bose-Einstein condensates. Danah Zohar adds that there's really no reason to deny that any structure containing a Bose-Einstein condensate might possess the capacity for consciousness.
A Bose-Einstein condensate. That's where atoms are cooled way down, near absolute zero, right? And they start acting like one single quantum entity.
Exactly. They lose their individual identity and behave as one coherent whole.
Okay, so an isolated particle, or one in a special state like a condensate, might have some degree of this awareness. But what happens when they interact normally, in everyday matter, when they become part of a larger system?
That raises a critical point, and the sources address it. They explain that the sort of low-energy, low-frequency particles described in the standard model can easily lose this property of consciousness.
Lose it.
When they become entangled with other particles, a process called decoherence sets in.
Decoherence.
Yeah.
Things getting messy, losing their quantum nature.
Sort of. Think of it like a metal object that can be magnetized. Individual atoms inside are like tiny magnets.
Right.
But if they're all pointing in random directions, the object as a whole shows no magnetic field. It's demagnetized.
Oh, yeah.
But if you align those atomic magnets, boom, the whole thing becomes magnetic.
I see the analogy.
In the same way, these sources suggest consciousness is exhibited when groups of particles are in the same quantum state, a state of quantum coherence,
Wow.
where their quantum properties are synchronized.
So coherence is the key.
It seems to be, which implies that the bulk matter we interact with daily, in our highly decoherent, low-energy, classical-looking universe,
Yeah.
exhibits an extremely low degree of consciousness, so low that for all practical purposes, it's effectively unconscious.
Effectively unconscious. Interesting. The author calls this whole field quantum metaphysics.
That's the term used, yes. It blends quantum physics concepts with these more metaphysical ideas about consciousness.
So the state the particles are in their quantum coherence is crucial for their conscious expression.
Mm-hmm.
But if these particles are aware in some sense, they must also be processing and storing information, right?
That's the logical next step.
Which brings us to another really astonishing claim from our sources: the incredible information storage capacity of these very same fundamental particles.
This part is truly fascinating, especially, for anyone interested in how much data can be packed into tiny spaces.
Like our listeners always looking to absorb knowledge.
Exactly. The sources tie this back to a thought experiment from Richard Feynman, the physicist, way back in 1959.
Feynman. What did he suggest?
He speculated that, theoretically, all the words ever written could be contained in a tiny cube of material, maybe 1/10 of a millimeter wide.
All words ever written in something that small. How?
If you could write using individual atoms as the bits.
Okay. That was theoretical then, but you're saying scientists have actually come close to doing that now.
Incredibly close. They have created atomic scale memory. Scientists have successfully used, for example, silicon atoms to store individual bits of information.
Wow.
And researchers at the University of Wisconsin at Madison have even read and written to a memory unit that uses a single atom to store a bit. And they did it at room temperature.
A single atom holding a bit at room temp.
Yep. The memory density they achieved is actually comparable to how nature stores data in DNA molecules. It's mimicking biology's efficiency.
Okay, but how much information could one atom really hold? The sources give an almost unbelievable example.
They do. Get this. The word opithecus has apparently been written on a single hydrogen atom.
The whole word.
Yeah.
On one atom. How is that even possible?
By manipulating its electron, they excite the electron into something called a Rydberg state.
Rydberg state. What's that?
Imagine the electron isn't just orbiting close to the nucleus, but expands way out into this vast, complex cloud around the atom. It becomes a wave packet.
A wave packet, like a spread out electron.
Kind of. And this wave packet can store incredibly intricate patterns. Think of it like a tiny, programmable hard drive made from an electron cloud.
Okay.
Carlos Stroud and Michael Null point out that an electron in, say, an N50 Rydberg state, that just defines how excited it is, has something like 2,500 possible states of angular momentum.
2,500 states in one electron.
Yes. And these states can be combined in various ways. It just demonstrates the enormous potential for these elementary particles to store and transport vast amounts of information.
Okay, that's staggering potential. So what does this imply for something as complex as, say, human memory? With all its sights, sounds, feelings, could our incredibly rich experiences genuinely be stored within some kind of wave particle structure?
Well, the sources suggest this is entirely plausible. Think about it. However complicated a wave is, mathematically, it can always be described as a combination of many simpler sine waves.
Right, like Fourier analysis.
Exactly. It's like how an entire orchestra's sound, all those complex frequencies and harmonies, can be reproduced by the single vibrating cone of a loudspeaker.
Good analogy.
So by modulating waves, changing their intensity, their frequency, or just switching them on and off, they can carry immense amounts of information. And the higher the frequency, the more information a wave can encode.
So storing memory in wave interference patterns.
Yeah.
It's efficient.
Remarkably efficient, according to these sources. They go so far as to claim that using holographic encoding of these wave interference patterns could theoretically allow all the books in the U.S. Library of Congress
All of them.
to fit onto a large sugar cube.
A sugar cube. That sounds like science fiction.
It really does, doesn't it? But it highlights the sheer information density potentially available at these fundamental levels.
Okay, so we've gone from potentially conscious particles to particles capable of storing unbelievable amounts of information. Now our sources pivot again into more metaphysical territory.
Yes, they start connecting these ideas to our very existence, things like memory, personality, even concepts like reincarnation.
How do they make that leap?
It connects to this idea of a physical-etheric nucleus. This is a term from metaphysicists Charles Leadbeater and Annie Besant. They called it a permanent particle.
A permanent particle, what is it supposed to be?
They suggested that each subtle body, which in these traditions means non-physical energy bodies like the astral or mental body, has such a nucleus, a core particle.
And what does this particle do?
It supposedly stores all the essential information about that subtle body, its composition, its frequency or vibration, its structure, and all its associated memories.
Okay, so this nucleus, the sources say it can act like a kind of black box flight recorder for a lifetime's worth of experiences.
That's the analogy they use, yeah. And it's quite a powerful one. This particle is considered analogous to what DNA is for the biomolecular body.
The blueprint and the record keeper.
Exactly. Hindu metaphysics apparently refers to these particles or nuclei as bindus, and in Tibetan yoga they're called drops.
Bundus, drops, permanent particles. Different names for a similar concept.
Seems so. According to Besant, these permanent particles preserve within themselves powers of vibrations, different frequencies and waveforms that encode the results of all experiences a person had.
All experiences, encoded as vibration.
That's the idea. So by the end of a physical life, this physical etheric nucleus would have stored up, as they put it, innumerable powers of vibration.
So following this logic, a personality is essentially just a packet of self-organized information, a complex waveform.
Pretty much, yeah. That's how it's framed.
And if this information, this packet, can be transferred, then the personality could, in some sense, continue, live on.
That is the profound implication they draw, yes. The information stored in this physical etheric nucleus could potentially allow a personality and its associated physical etheric body to be, well, reconstructed.
Reconstructed, like rebuilding it.
Or resurrected in a similar physical etheric body later on. They suggest a process analogous to teleportation information transfer leading to reconstruction.
Teleportation, wow.
And some sources connect this to plasma metaphysics, suggesting the physical etheric body provides a kind of electromagnetic template or matrix that's crucial for morphogenesis, that is, the shaping and development of the physical biological body.
So it provides a non-physical blueprint.
Essentially. And this provides a theoretical basis within this framework for concepts like reincarnation or resurrection.
Okay, I'm trying to follow this. This physical etheric nucleus, this permanent particle, it's the key to transferring information between lives, or even between universes.
That's what's suggested. It enables the transfer of information from one body, maybe in one universe, to another body, perhaps in the same or even a different universe, during the death process.
So without this transfer, the experiences would be lost.
Accessing or reconstructing experiences from the physical universe later might be difficult, yes. The sources suggest that fundamentally our self-information would need to be uploaded somewhere else.
Uploaded, like data.
To another player or body, as one source puts it, to continue personal existence. And they argue that advances in science, particularly in understanding information storage in particles,
Right, the Rydberg atoms and stuff.
suggest these nuclei could theoretically carry a huge volume of complex, maybe even holographic information about their corresponding bodies and experiences.
Holographic information, meaning the whole is contained in every part.
Something like that, yeah. Very dense, very interconnected information storage.
Okay. Connecting this back to the physics side, the sources also discuss conscious fields and waves. How does that fit into this bigger picture?
Well, according to quantum electrodynamics, or QED, which is our fundamental theory of how light and matter interact,
Right.
particles aren't really tiny solid balls. It's better to think of them as excitations, like energetic ripples or vibrations within a continuous underlying field that permeates all of space.
So fields are fundamental, particles are just disturbances in the field.
In a sense, yes. All particles have associated fields, and all fields have associated particles. They're two sides of the same coin.
Okay.
So the logic follows. If a superparticle, like a boson-Einstein, condensate acting as one entity, exhibits consciousness.
than the underlying field it came from.
The field itself could also carry that intelligent behavior. Consciousness inherent in the field, even without a localized physical form.
A conscious field. And particles also behave as waves, as we discussed with the double slit experiment.
Exactly. And Bose-Einstein condensates, again, are a great example because they clearly exhibit both behaviors. When that gas is cooled way down, the atoms lose their individuality. They merge into this single quantum entity, this superatom, behaving coherently like photons in a laser beam.
Right.
And then they clearly show quantum phenomena like wave-particle duality. They can act like a single particle or spread out like a wave, and even do things like quantum tunneling.
Tunneling through barriers they shouldn't be able to cross classically.
Precisely. So the implication is that conscious particles, if they exist, can also propagate as waves. It further unifies these seemingly separate concepts, consciousness, particles, waves, fields, information, into one integrated reality.
Where information, consciousness, and matter are all deeply, fundamentally intertwined.
That's the picture these sources are painting.
Wow. This has been a truly thought-provoking deep dive. We've journeyed from the really radical idea of individual particles having some rudimentary consciousness and the mind-boggling capacity of atoms to store vast amounts of information.
The sugar cube library.
Right. All the way to this metaphysical framework suggesting our memories, our personality, might be encoded in a permanent particle.
A bindu, or
Capable of transferring across different states of existence, maybe even universes.
it really does highlight how the concept of consciousness might be far more pervasive, far more fundamental to reality than we typically imagine.
Not just in brains, but everywhere.
Woven into the very fabric of existence, right down at the most elemental levels. It forces us to reconsider where the boundaries of life or awareness truly lie.
Absolutely. And this leaves us with a truly compelling question for you, our listener, to really, mull over. If consciousness and memory are potentially so intrinsic to the smallest building blocks of reality, what might that imply about the nature of our own consciousness? Where does your self truly reside?
A profound question to end on.